The properties of the joint distribution function V is defined by using only two random variables x and y here. So the first property says that the joint probability distribution function at x is equal to minus infinity, y is also minus infinity. That is fxy minus infinity will be 0. Okay. Similarly, fxy x comma minus infinity will be 0. And fxy minus infinity comma y is equal to 0. This is our first property. And what is the second property here? Fxy infinity comma infinity will be equal to 1. Okay. So 0 less than or equal to fxy of x comma y is less than or equal to 1. So it shows that what is the minimum value of joint probability distribution function will be 0. The maximum value will be equal to 1. Okay. So then the fourth property says that fxy of x comma y is monotonic on the non-decreasing function of both x and y. Okay, so that is joint probability distribution function is monotonic and non-decreasing function of both x and y. So it is increasing function. Okay, the fifth property says that the properties of joint event. What is the joint event here? X1 less than x less than or equal to x2, y1 less than y less than or equal to y2 is given as. So what is the probability of this? Probability of x1 less than x less than or equal to x2, y1 less than y less than or equal to y2 is equal to, it is given as fxy, that is joint probability distribution function at x2 comma y2, fxy at x1 comma y1 minus fxy at x1 comma y2 minus fxy at x2 comma y1. Okay, so this is our fifth property. The sixth property says that marginal distribution functions are given by. So what are the marginal distribution function? That is fx of x and fy of I. These are called marginal distribution functions. How do you obtain marginal distribution function? By considering other random variable as infinity. Okay, so fxy x comma infinity is equal to fx of x fxy infinity comma y. So here x is infinity, so whereas y we are considering, so we are getting fy of y. So these are the marginal distribution functions, that is fx of x and fx of y. So that is we can obtain marginal distribution function from joint distribution function. Okay, now we'll see the proof of this. Okay, so what is the first property says? That is fxy of minus infinity comma minus infinity is equal to 0. Fxy minus infinity comma y is also 0. Fxy um, minus infinity, sorry, x comma minus infinity is also 0. That is, now what is that we are doing? We are considering two random variables x and y. So what are the events here? The event A is defined as A is equal to x less than or equal to x, B is equal to y less than or equal to y. Okay. Now what is joint probability distribution function? Fxy of x comma y is equal to probability of x less than or equal to x and y less than or equal to y. Okay. So that is equal to probability of x less than or equal to x intersection y less than or equal to y. This is the definition of joint probability distribution function. That is fxy of x comma y is equal to probability of x less than or equal to x, y less than or equal to y. That is equal to probability of x less than or equal to x intersection y less than or equal to y. Okay. Now what is that we are doing? We have considered x is equal to minus infinity. So now we know that we don't have any event at x is equal to minus infinity. So what is the probability of x is equal to minus infinity will be 0. Similarly, probability of y is equal to minus infinity, we don't have any element at y is equal to minus infinity. So what is the probability of y is equal to infinity is minus infinity is also 0. So then at x is equal to minus infinity and at y is equal to minus infinity, we don't have any elements. Okay, so that is why the joint distribution function fy of minus infinity comma minus infinity can be written as probability of x less than or equal to minus infinity intersection y less than or equal to minus infinity. So you don't have any element here, it is null set. Here also we have null set. So what is this intersection? This intersection gives us null set. So we know that probability of null set will be equal to 0. So this prove our first part of first property. What is that? Fxy of minus infinity comma minus infinity will be equal to 0. Now we have taken x is equal to minus infinity. If you take x value less than or equal to minus infinity, what happens? This gives us null set. What is this? This is null set intersection y less than or equal to y. So you know that null set intersection with any set will be equal to null set only. So what is the result? We get null set. So probability of null set will be what? The probability of null set will be equal to 0. Similarly, if you take y is equal to minus infinity, so just now we have discussed that y less than or equal to minus infinity will give us null set. Okay, so any set intersection with the null set will give us null set only. So what is the probability of null set? Probability of null set will be 0. Okay, so this will prove our first property. Now what is the second property? The second property says that fxy of infinity comma infinity is equal to 1. Fy of x comma y of infinity comma infinity is equal to 1. So this can be written as probability of x less than or equal to infinity intersection y less than or equal to infinity. Okay, so whatever, see here, whatever term you are taking here, here infinity we have taken, no, so we have to take x less than or equal to infinity, y less than or equal to infinity, intersection of that. Okay, so what is x less than or equal to infinity? X less than or equal to infinity is nothing but it will include the complete sample space. Okay, so we'll be having all the elements of x. All the elements of x is nothing but the sample space. Okay, and similarly all the elements of y is nothing but sample space. Okay, so the sample space intersection sample space is nothing but what? The sample space only. So what is the probability of sample space? The probability of sample space will be equal to 1. Okay, so this is our second property. Okay, so from the first property we know that if fxy of minus infinity comma minus infinity will be 0, from the second property we know that fxy of plus infinity comma plus infinity will be always 1. Okay, so from the property 1 and 2, so we know that fxy of minus infinity comma minus infinity, so that is the first property, will be always equal to 0. Fxy of infinity comma infinity, that is the second property, will be always equal to 1. And we know that since x value is varying from minus infinity to plus infinity, y value is also varying from minus infinity to plus infinity. So from these two properties, we know that what is the range of fxy. So the range of fxy, that is joint probability distribution function, is between 0 and 1. So what is the minimum value will be 0 and maximum value will be 1. Okay, similarly x1 comma x2, the fourth property. What is the fourth property here? So we are taking two elements x1 and x2. Y1 and y2 are the two elements in the sample space. So how we are taking these elements? We have taken such that x1 value is always less than or equal to x2. Y1 value is always less than or equal to y2. Okay, so in that case, say for example, here it is considered like this. What is our range x value? Say it starts from 0. Our x1 is here. Okay, this is our x2. This is x2. So similarly, now we just take the y range. Y value is 0 here. This is our y1. Okay, this is our y2. It is given like this. Okay, so in that case, what is x1? X1 is taken such that x1 value will be always less than or equal to x2. Y1 value is always less than or equal to y2. Now this complete range, what is the complete range here? The complete range is 0 to x2, no? 0 to x2 we divide into two parts, 0 to x1 and x1 to x2. How do you get 0 to x2? 0 to x2 can be divided into two parts, 0 to x1 and x1 to x2. So x1 less than or equal to x1, x less than or equal to x1, y less than or equal to y1 plus, and what is the range here? X1 to x2, no? X1 less than, x less than or equal to x2, y less than or equal to y1. We are not changing the y range. Y range is taken as 0 to y1 only. So 0 to y1 we have taken for y, whereas x1 range is we have to take as 0 to x2. 0 to x2 we divided as 0 to x1 and x1 to x2. Okay. So that is why we are getting two terms here, that is equal to x less than or equal to x2, y less than or equal to y1. Okay. Now we apply probability on both sides of this equation. So if you apply probability on both sides of this equation, so what is that we get here? Just observe, it is probability of x less than or equal to x1, y less than or equal to y1 plus probability of x1 less than, x less than or equal to x2, y less than or equal to y1. So that is equal to what? Probability of x less than or equal to x2. See here, probability of x less than or equal to x2, y less than or equal to y1. Okay. So now what is this equation? This equation is nothing but the joint probability distribution function. So how do you write it as? If we write it as fxy of x1 comma y1. Okay. Then the second term will be like that only. It is the probability of x1 less than, x less than or equal to x2, y less than or equal to y1. So what is the right side of this equation here? It is the joint probability at x2 and y1. Okay. So it is fxy of x2 and y1. Okay. So from this equation, what is the probability of x1 less than or equal to x2, y less than or equal to y2 will be fxy of x2 comma y1 minus fxy of x1 comma y1. Okay. So from this we know that what is fxy of x2 comma y1 will be always greater than, because this term plus this term, these two, addition of these two terms only give us this. Yes or no? So that is why this term, that is fxy of x2 comma y1, fxy of x2 comma y1 is always greater than fxy of x1 comma y1. Okay. So that is why from these two relation we know that what is probability of x1 less than, x less than or equal to x2, y less than or equal to y1 value will be always positive. It is always positive because just now we have discussed that fxy x1 comma y1, fxy x2 comma y1. Okay. So this term fxy x1 comma y1 will be always less than or equal to fxy x2 comma y1. Okay. Similarly, so in this previous case, what is that we did? We have changed x1 range, y1 range we kept constant. Okay. Similarly here also x1 is kept constant, y2 range is varying from y1 to y2. Okay. So it is similar to the procedure whatever we have discussed just now. Okay. That is from that we can know that fxy of x1 y1, fxy of x1 y1 will be always less than or equal to fxy of x1 comma y2, because y2 value will be always greater than y1. So what is that? This value, the probability of this value will be always greater than this value. Okay. So from this relations we can know that what is the joint probability distribution function at x1 y1. Joint probability distribution function at x1 y1 will be always less than or equal to joint probability distribution function at x2 and y2, because x2 and y2 will be always greater than x1 and y1. So the joint probability of this fxy of x2 y2 will be always greater than fxy of x1 y1. Okay. So from these three relations we can say that fxy of x1 x comma y is monotonic and non-decreasing function. Okay. So this is our fourth property. Now we'll see the fifth property. The fifth property says that since x1 is less than or equal to x2, y1 is less than or equal to y2. Okay, so what is that we have considered? X1 is less than or equal to x2. So x1 will be before x2, less than or equal to x2. And what is y1 range? Y1 is also less than or equal to y2. Y1 is less than or equal to y2. Okay, so this we have just now we discussed. Okay, so from this, what is the range here? Just observe this. This can be written as x1 less than x less than or equal to x2. Means we have interested with this range. Okay, x1 to x2. What is y range? Y range is also given as y1 to y2. Okay, so from this, how do you get this range, ma'am? X1 to x2. How do we get this range? This range we get by taking the x2, the complete x2, okay, minus x1. X2 minus x1 will give us the range from x1 to x2. Yes or no? So that is why, what is that we are doing here? We are writing it as x less than or equal to x2, y1 less than or equal to y less than or equal to y2, minus x less than or equal to x1, y1 less than or equal to y less than or equal to y2. Okay, now what is that here? See, how do you got this relation? Y x1 less than x less than or equal to x2, x1 less than x less than or equal to x2. How do you got? By taking x less than or equal to x2. See here, by taking x less than or equal to x2, then minus x less than or equal to x1. Okay, so by taking this two conditions, we got this range. Similarly, to obtain y1 less than or equal to y less than or equal to y2, y1 less than y less than or equal to y2, what is that we are doing? The same relation we are using. What is the relation? Y less than or equal to y2 minus y less than or equal to y1. Like that we are using the same relation. Okay, so from that, what is that we are getting now? We are dividing this into four parts. What is that here we are doing? We are combining these two, that is x less than or equal to x2, y less than or equal to y2. This is worst combination. Then x less than or equal to x2 minus y less than or equal to y1. Okay, so this minus we are writing outside. So x less than or equal to x2, y less than or equal to y1. Okay, similarly this also will be combined like this: x less than or equal to x1, y less than or equal to y2. Here we have already minus, no? Minus and minus, so it becomes plus. So it is plus x less than or equal to x1, y less than or equal to y1. Like that we are getting four parts here. Okay, now we take probability on both sides of this equation. If you apply probability on both sides of this equation, what is that we get? Probability of x1 less than x less than or equal to x2, y1 less than y less than or equal to y2 can be written as, what is this here first term? Probability of x less than or equal to x2, y less than or equal to y2. Okay, now probability of x less than or equal to x2, y less than or equal to y1, minus probability of x less than or equal to x1, y less than or equal to y2. And similarly the last term plus probability of x less than or equal to x1, y less than or equal to y1. Okay, so we are getting like this. Now we know that what is this? Probability of x less than or equal to x2, y less than or equal to y2. Probability of x less than or equal to x2, y less than or equal to y2 is nothing but what? It is the joint probability distribution function at x2 comma y2. Okay, similarly, what is this? This is joint distribution function at, see here, what is that we have? X2 and y1. So it is joint distribution function at x2 and y1. Similarly, what is this here? This is the joint distribution function at x1. See here, it is x1, y2. So it is joint distribution function at x1 and y2. And this term, the last term, is nothing but it is the joint distribution function at x1 y1. Okay, so that is the fxy of x1 comma y1. Okay, so this is our fifth property. Okay, now we'll see what is sixth property. We'll be obtaining marginal distribution function. What is marginal distribution function? The marginal distribution function is nothing but fy of y and fx of x. Fy of y and fx of x are called marginal distribution function. Okay, now see here, probability distribution function fxy of x comma y. Fxy of x comma y can be written as probability of x less than or equal to x, y less than or equal to y. Okay, now what is that? It is intersection of these two events, that is probability of x less than or equal to x intersection probability of y less than or equal to y1 y. Okay, now at x is equal to infinity, at x is equal to infinity, fxy of x comma y, at x is equal to infinity, fxy of x comma y is equal to what? So now x value is infinity, so it is probability of x less than or equal to infinity intersection y less than or equal to y. Okay, now what is x less than or equal to infinity? X less than or equal to infinity is nothing but sample space. It will have all the elements. Okay, so it is S intersection y less than or equal to infinity. Now you know that any event, this is the event, no? Intersection with the sample space. Any event intersection with the sample space will give us the same event. Okay. So S intersection y less than or equal to y will give us y less than or equal to y only. So what is the probability of y less than or equal to y? Y less than or equal to y, the probability of y less than or equal to y is fy of y. Okay, so this fy of y is called marginal distribution function. Now what is that we have done here? We have considered x is equal to infinity. X is equal to infinity, that is why fxy of infinity comma y will be equal to fy of y only. Okay, now what is that we have done? We have considered y is equal to infinity. Now if you take y is equal to infinity, what is the y limit here? Y limit will be y less than or equal to infinity. X will be the same, x less than or equal to x. Okay, y less than or equal to infinity is what? Y less than or equal to infinity is nothing but the sample space. So probability of x less than or equal to x intersection sample space. So what is this term? This term gives us the same event, that is x less than or equal to x only. Okay, because any event intersection with the sample space will give us the same event. Now what is that it gives? If y is equal to infinity, then it gives us fx of x. What is fx of x? Is called marginal distribution function. Okay, so this is our sixth property. So from this, fxy of x comma infinity will be equal to fx of x only. Okay, so that therefore the marginal distribution function of joint distribution function are equal to what? The marginal distributions of joint distribution functions will be equal to individual probability distribution functions. Okay, so this is our sixth property. Okay, these are the properties of joint probability distribution function.